Alrighty, good afternoon, everyone. It is June 10th, a Tuesday at 6:17 p.m. I guess it's closer to evening now, huh? I think this marks day 16, so we shall continue. So, I'm thinking about heading up a sliding window for our next step. Thinking about doing sliding window, and then we'll hit binary search, and then we'll go to trees. Um, Sorry about that. So yeah, let's go ahead and let's just start off. Throw ourselves in here. Let's open up our drawing board, which we got a lot of stuff being written out over here. I guess these are all being saved as SVGs. Pretty smart. So given the string S, find the length of the longest substring without duplicate characters. What am I doing? I'm doing sliding window, right? Okay. Given the string S, find the length of the longest substring without duplicate characters. Okay. So I'm going to say left pointer is equal to oh my gaze. Hold on. I'll be right. Let me. Alright, I'm back. Sorry. I think someone did not have a good day at work because they are slamming the silverware as they are putting it away, which is super loud. Okay. Wait, what am I doing? Okay. Oh, I remember doing this from a long time ago and I couldn't figure it out. It's so interesting how like now, kind of knowing what kind of algorithm it would be becomes much easier. Ah, God, I love the continuation of programming of like the knowledge you just pack on as you go. But okay, basically, if you are wondering what my ideation is, I'm going to store a string or an array or however you want to put it of these characters, and then basically, if I run into a new character that is in the previous one, I'm just going to move my left pointer to the right side. So it'll basically be this has to be the very end. Okay. Doing this as a visualization test. Python, you know how it goes with Python. Oh, yeah, silly guy. Yes, we're missing the last one. Go figure. Huh. Oh, wait. Yeah, here you go. That's more like it. I think I'm doing my numbers wrong here. I might have to draw this out so I can visualize this properly, because I'm on the right track. I'm hitting that silly kind of wall you hit. Oh, okay. So, if R is an A, then left becomes R, so not much changes here. Just kind of stays the same. And then R moves on. Oh, wait. Hold up. S equals nothing. So is A in here? No. Doesn't matter. We'll append A to it. Then we move on to B. So now we have, is B in that one? Nope. Append it. Then we move on to C. Is C in that one? Nope. We append it. Then we move on to D. Oh, stupid. Let me fix this. Move on to A. So we have a max equals 3. Is A and ABC? It is. So we're going to reset this to blank. Move that over here. Okay. And then I'm going to say, is C in A? Oh, we're going to say, sorry, is C in A? It is not in A. So I'm going to add it. This is Um, yeah. Okay, so I had a feeling that was gonna be the case. I want to be forever young. It's my cat. You're probably hearing. His dinner time's coming up soon, and he kind of knows it, so he's a little active right now because he wants his food. But I have to make him wait because he used to be an obese cat before I got him, and so you have to put a little bit of constraints on him so he doesn't get obese again. He used to be a really big boy. Oh, I left the +1 in there. There you go. Hey, cat. Smith it. I hear you. Wrong answer. What? DVDF. What? Oh, VDF. Ow. Right. I'm saying left pointer to right pointer. What am I doing? I'm not supposed to do that. I'm supposed to do left pointer is equal to the position. I knew that beforehand. I just forgot about it when I did my Scally draw. Silly guy. So not this. That's wrong. It's going to be left pointer is equal to how to find the index of an element in list Python. Oh, in a string. Index. Alright, dope. Freaking love Python. Sub dot index of this character. I wanna be forever young. So I have a feeling this might not work. Plus left pointer -1. So I'm thinking. Whoa, maybe a little too much, huh? Okay. Actually, no. Max. Max. Stop it. Stop! I know, I hear you, dude. So plus, is that what you do? Plus one? Oh, okay. There you go. La Beautiful. That was a fun problem. Okay, longest repeating character replacement. I am given a string called S and an integer K. I can choose any character of the string and change it to any other uppercase English character. You can perform this operation at most K times. I need to return the length of the longest substring containing the same letter you can get after performing the above operations. First, that would be DP, but I'm just letting them know. I hear you. Dude, trust me. You'll be fed very soon. Don't worry. I'm not gonna abandon you, bro. Okay. So, I'm guessing... but here's the trick. It's like, this could go either way. You know? Like, I could replace the B's with A's, or I could replace the A's with B's, you know? Like, how do you know which one? Dude, I'm not gonna lie, this one's kinda got me cooked. I don't even know where to begin on this one. This one just looks like DP to me. It's been a minute since I've done DP too. An O of M space. O of M space. So I make like a list of the unique characters. Which character would you place in the string to make all its characters unique? Can you think with respect to the frequency? Oh, don't. I would replace them with the least frequent. I hate when they start saying frequency because it starts scaring me. Like, I'm not doing a bubble sort, right? Not a bubble sort, a bucket sort. I'm guessing I'm going to... So hold on, before I read this sentence. My assumption is I'm going to use a dictionary. That's the OVIB, and I'm basically going to track... I'm going to do a linear pass once to find the frequency, and then based off of that, I'm going to try to replace the one with the lowest frequency with the one with the highest frequency. It's my assumption. It's always optimal to replace characters with the most frequent character in the string. Most? What? That confused me. Dude, I have no idea. I feel like there's so many paths you can go with this. Okay, we'll just do hash map. Um, pretty sure Python auto initiates it to be 0. Oh, it doesn't. This is a really stupid approach, but yeah. I have no idea how to do this. You know, hold on. I want to see another case. This is a little bit of hard coding because I want to see the other cases, because these cases are not really helping me out with my theory crafting. Oh, oh, yeah, D. Hasmap. Has. Okay. I passed 7? Huh? Maybe it's going in different orders. Brother, that is like a horrible test case. My god. I don't know if there's multiple caricatures, you know? They're not really giving me much to go off of here. Oh, whoops, turn 3. What am I saying? Brother. Ah, okay. I guess it's just 2 characters because there's no shot at anything else. The way they are acting. This is off rope. Not good. Alright, no, I give up actually. I don't think I'm gonna do this one. This one's kind of confusing me.
Hey everyone, welcome back, and let's write some more neat code today. So today we're going to solve longest repeating character replacement. And so this is another problem from that blind 75 list. So we're going to be one step closer to completing the entire list. The link will be in the description to the spreadsheet if you do want to take a look. And hello to the 6 people that are currently viewing the spreadsheet right now. You're going to be in the next video. But okay, so let's get into this problem because it's another pretty fundamental problem that's really good to understand. So we're given a string s and a single integer k. And so basically they tell us that we can choose any of the characters in the string and change it to any other uppercase English character. So in this problem, every character in the input string is going to be limited to uppercase English characters. And we know that there's 26 uppercase English characters from capital A to capital Z. And so basically we can perform a replacement on any of the characters at most k times. So we're allowed to replace k different characters in the string to any other character we want. And what we want to do is return the length of the longest substring containing the exact same character we can get after performing at most k different replacements. So we just want to return that length. We don't actually have to make those replacements in the input string. So in this case, when we take a look at the input string, we have AB, and we're allowed to replace 2 of the characters. So what's the longest substring we could get with the exact same character? Well, we could replace one of the B's. We could basically replace both of the B's with a capital A, and then we get 4 A's in a row, which would give us an output of 4. And we could technically also do the opposite. We could replace the A's with capital B's, and that would give us the exact same result, a length of 4. So I'm going to show you how you can solve this problem in big O of n time, and technically it's going to be big O of 26 multiplied by n, which we know is also reduces to big O of n. But there's actually technically an easier way to do it, or at least a more simple way to do it, which is just going to be a flat big O of n. We don't even need this 26 constant. But this way is actually pretty tricky to get to, so I'll be going over a little bit of it, but this is kind of the main way that you want to solve this problem. So let's say we're given an input string like this, and we're given a k value. Now the most brute force way would just be check every single substring, right? And if we were checking every single substring in the entire input array, we know there's n squared substring, so that wouldn't be the most efficient way to do it. But even if we were doing it like that, what exactly are we looking for? If we're looking at a particular substring, how do we know if this substring is valid? Because remember, at the end of the day, we want to maximize the result, right? The result is going to be the longest substring that contains a single character, and we can make 2 replacements. So let's look at this substring alone. How do we know if it's valid? Well, which character are we going to replace? Are we going to want to replace the B's in order to make it all be to match A, or would we want to replace the A in order to match it with the rest of the B's? Of course, we're going to replace the character that occurs less frequently, right? Because the number of replacements we have is limited, so we would want to replace the characters that are less frequent. So in other words, we want all characters in a particular window to match the most common character in that window. So what we're going to be doing is we are going to have a hash map or a array, which is going to take every single character. In this case, we only have characters A and B, and we're going to count the number of occurrences of each character. So for example, if we were looking at this substring, we see that there's 3 B's and we have a single A. So how do we know if this window is valid? What we're going to do is we're going to take the length of the window, which is going to be 4, right? We're going to take the length of the window, right, which we know in this case is 4, and we're going to take the length or the count of the most frequent character. In this case, we know that that's B, and the count of it happens to be 3, so we're going to take 4 minus 3, and from that, we're going to get a 1. Now, what does this value 1 tell us? It tells us the number of characters in our window right now that we need to replace in order to make it match the most frequent character B, right? We have a B here. We want everything to match a B. In this case, we only have an A, right? But it could be possible, like, who knows, maybe that we have a C over here, right, or an X over here, and it doesn't really matter what the characters are. We just know that B is the most frequent character in the window, and the other characters that are not B, A and Z, for example, are the characters we want to replace. So we can calculate the number of characters we want to replace just like this. And so we want to replace one character. How do we know if we have enough replacements to do one character? Well, of course, that's our input parameter k, right? So what we're confirming here is that this value is less than or equal to k. As long as this condition is true, that means our current window is valid. That means we have enough replacements to make.
But if it's not, then you just make the window smaller. Huh. Okay.
Replacements in our current window. So this is the main condition that we're going to be checking. The other question is, how are we going to know which character is the most frequent? Well, the brute force way is going to be taking a look at our map of counts, and we know that the max size of this could possibly be 26 because we'd only have 26 different characters. So finding the max character is going to be big O of 26. So that's a little bit more inefficient than we would like, but it's technically still linear time. Like the overall algorithm is still going to be linear time. The last thing that we're going to have to do though is to this equation, we're going to have to add a sliding window technique. So basically what we're going to do is we're going to take our window, start at the beginning, expand it as much as we can, as long as the condition that we mentioned is valid. If the condition is not valid, then we're going to take our left pointer and then shift it as well until the string becomes valid once again. So we're going to have a left and right pointer. So initially left is going to be at the beginning and right is also going to be at the beginning. And also the counts of A and B are initially going to be 0. Now we're going to look at the first character, right? That's where our right pointer happens to be. We're going to look at it. We're going to say, okay, we have a single A, right? We're going to take our count of A and set it to 1 now. So is this window valid? As in, can this window be the exact same character within 2 replacements? Of course it can, right? That's kind of the trivial case, but we would still calculate it. And the way we would calculate it is get the size of our window. Right now we can see the size of our window is 1 subtracted by the count of the most frequent character. In this case, we know the most frequent character is A. 1 minus 1. Is that less than or equal to K? We know K is 2. So of course this is going to equal 0. 0 is less than or equal to 2, which is K, right? So of course this window is valid. That's kind of a trivial case. Next, we're going to shift our right pointer to the next character, right? So now we have a B, so we're going to increment the count of B in our map. So B is now going to be set to 1. In this case, the length of our window is 2. The most frequent character is either of these, right? And the count of that frequent character is going to be 1. So we're going to have 2 minus 1 equal to 1. So this is the number of replacements that we would have to do. And looking at our current window, that makes sense, right? We'd have to replace at least one of these 2 characters. So we're going to ensure that the number of replacements that we need to do is less than or equal to K, which is 2. Of course, that's true. So our window is currently valid. I guess I did forget to update our result. So since this window is valid, the length of the window is going to be set to the result, right? So right now the result is 2. 2 is the length of the longest window that we can get. So that's our result for now. So now let's continue. Next, we're going to shift our right pointer to the third character. So now we get another A, so we're going to take the count of A and increment it all the way to 2, and we're basically going to repeat our algorithm. So once again, we're going to get the length of the window 3 minus the count of the most frequent character. We see the most frequent character is A, so the count of it is 2. 3 minus 2 is 1. Is that less than or equal to 2, which is K? Yes, of course it is. So this window is also valid. We can update our result now to 3. So we found another window even longer. So I'm going to take our right pointer once again and then shift it over to the B. So now we're going to be, since we reached another B, we're going to increment the count of B to 2 now. And so the length of our window now is 4, and the count of the most frequent character is either of these, and that's going to be 2. 4 minus 2 is equal to 2. Is that less than or equal to K? K is 2 in this case. So of course, once again, this condition does hold. So once again, we found a window that's longer than our result. We found a window now of length 4. And so once again, we're going to take our right pointer and shift it. So now another B. Let's increment the count of B to 3. So the length of the window now is 5 minus the count of the most frequent character. That character is B. 5 minus 3 is this 2, and less than or equal to K. Of course, it's still true because when you look at our window, we have 3 Bs. So that means we're going to be replacing the A's. So we're going to need to make 2 replacements, and we are allowed to make 2 replacements. Okay, so now we're finally going to get to the case that I mentioned earlier, where we're going to have to take our left pointer and then slide it to the right, which is why this is a sliding window problem. So now we reached an A. So we're going to take the count of A and set it to 3. So now we have A count 3 and B count 3. So let's take the size of our window 6, subtract from it the count of the most frequent character. It's going to be either of these. So 6 minus 3 means we need to make 3 replacements. Is that less than or equal to K? K is 2. So we exceeded K, right? We exceeded the number of replacements we're allowed to make. If we wanted this window to be valid, we have to replace 3 characters in it, but we're not allowed to do that. So what we have to do is shrink the size of our window until we are valid. So we're going to take our left pointer and shift it to the right. So now the left pointer is going to be over here. It's going to be at the B. So since we removed this A from our window, we have to decrement the count of A in our window. So I'm going to cross this 3 out, and now it's actually going to be set to 2. I kind of ran out of room, but I hope this is still readable. So now the count of A is 2. So now let's once again check, is our window valid? Well, the size of the window now is 5, and the count of the most frequent character is B, and that's going to be 3. So 5 minus 3 is going to be equal to 2. Is that less than or equal to K? Yes, we are once again valid. So this is technically a valid window, and I think I forgot to update the result earlier when we had a window of size 5. So the result right now would be size 5, because the longest window we can make is either this window or the window that we had earlier with these first 5 characters. But yeah, and so at this point we would stop our algorithm because we did find a window of 5 that is valid, and our right pointer cannot be shifted anymore. So this is the general algorithm. So it's a basic sliding, it's a fundamental sliding window problem with this particular condition being important. But there's actually one way you can do it without having to look through the entire hash map every time you want to find the most frequent character that occurs. And it's kind of tricky to arrive at the solution, but it's pretty easy to implement once you can figure it out. I'll explain the algorithm at a high level. I don't want to waste too much time on it, but basically we're going to be having another variable, and it's going to be called max frequency, basically the count of the most frequent character at any given time. So basically, for example, if we had A as a count of 3.
Okay. With that mathematical explanation, I think I can get this done. I'm gonna feed my cat. Be right back. Yeah, brother. Good okay. All right. But hey, what am I saying plus equals 1, 4? Writing this out, it's probably like a function here. Huh? It should definitely be a character. What did I do?
Less than or equal to k? Yeah.
Okay. Let's bounce around this and let's see what is causing the issue here. So, starting off with my right pointer is definitely less than the length. Window size is going to be 1 right now. I'm like totally brain farting right now. My brain actually just like went completely fried mode. I am getting hit by the sleepiness right now, brother. window size should never be 0. So why is it 0? Why is left pointer ever greater than right pointer? Should not be the case. I mean, this will fix my problem per se, but like that's not. I have this weird feeling that my max char thing is not really working like I would like it to. Or my hash map's not really working. Okay, that was it. I wasn't returning the max value. Yeah, that one's it's an important one. I'm assuming. I sucked ass. I'm not really a fan. Well, we're gonna move on. I'm gonna have to come back to this when I feel more awake, because right now I am dead tired. Given two strings, string 1 and string 2 return true if string 2 contains permutation of string 1 or false otherwise. Oh wow. What? Oh, of a permutation? Any permutation. What? Wait. No, because the permutations can be massive. This must be like. This must be count. It can't be actual permutations. Because, like, the brute force solution to this would be. Sorry. Brute force with sliding windows solution would be enormous. I mean, the permutations is like a factorial, right? Like, that would be massive. It would literally be k factorial, where k is the length of S1. This has to be counts. I cannot be actually doing the characters themselves. I have to be basically counting the characters. Wow. Holy hell. Okay. I'm gonna call this one S1 count. So equal to that. And I'm gonna say for element in S1. If element not in S1 count, then S1 count of element is going to be equal to 0, and then okay. So I can see your count. So this is how this is how I'm assuming you'll find your permutations. Okay. So this is very similar to the last problem. I'm just going to say new element is equal to S2 of right pointer. La pointer. Oh, no, any permutation's fine. this is horrible. Do I even need his left pointer? I'm gonna keep it for now, but I'm honestly like I don't even think I need left pointer. This is horrible. This is so chopped. This is like hella space complexity, dude. I don't even know what I'm doing right now, man. I didn't want to do this one. I'm like actually so tired. Yeah, I don't need to jump the gun. I just need to slowly move it along. Yeah, okay. So we're doing way too much space complexity right now. Oh, that counts as a 1. Come on, bro. I mean, yeah, I guess that makes sense. Bless you. Um, is it ORD or is that C++ or D? Nope. Nice. Okay. It's a really silly way of going about it. But it might work. It's also probably could exceed memory. Or it might work. It's a fast way, as you can see, very fast, but it's a lot of space. It's probably a better way of going about it, but yeah. That's what I did. What I did! Alright. Dope. Check that off. I think we got some hards to do, but that's not today. That's not today. Oh, they actually have... Oh, I mean, I saw those earlier. I didn't know those were prerequisites. Anyways, it is 7:39 p.m. Makes it, what, like a little bit over an hour. Yeah, thank you for watching. And I will see y'all tomorrow.